Thank you for having me here today. We're going to talk a little bit about things I think that are important to accomplishing IoT and IIoT related accomplishments. One of the things that concerns me more than anything else is in the future, IoT and IoT will eventually blend to become one thing, and it'll touch everything that we do, every aspect of human existence and interaction. So to this effect, I think it's important to understand and get out in front of what we expect to see in the future, what our vision is for the future, so we can make it happen according to what we think it should be in order to elevate the human condition, in order to elevate human existence. The future isn't really 5 years ago, 4 years ago, 3 years ago, we used to say this will happen when. And now we're saying, no, it's happening now. In fact, some of the things that are happening now that are supposed to happen tomorrow happened yesterday. So the future's here now, and we've got to be prepared to deal with it. So the art of how the art of the impossible is becoming possible today, yesterday, and tomorrow. Okay. As far as secrets to fully understanding and embracing IoT and OT, we have to maintain a vision. There has to be some master plan why we're doing what we're doing. Otherwise, we're like ants. We just do minuscule accomplishments, rebuilding the old, without moving forward. So it's necessary to have a vision to engage in the connectivity necessary to accomplish the dream. How do we go from the step that we're doing on Monday to the step we're doing on Tuesday to the step we're doing on Wednesday? What's the interrelationship? Again, according to this master vision. Know that innovation leads to realization and implementation. Innovation, even upwards of a few years ago, even today, a company has 5 bad quarters and all of a sudden innovation's a bad word, cut the budget. Okay, and in that period, what happens? What happens during COVID? Well, a lot of organizations rolled backwards. And when I say backwards, they rolled backwards people-wise, they rolled backwards civil service-wise, they rolled backwards in terms of finance. So, but the companies who matured, who moved forward during a COVID, they knew that they could use the period to learn, to study, to implement. We're going to be looking at 2 examples in this session, and one has to do with process optimization in terms of using machine learning operations and artificial intelligence. Another one has to do with connected worker, which will demonstrate how IoT and OT convergence is being utilized to enhance people, safety, ability, and efficiency. Remember, I mentioned that IoT, OT convergence, togetherness, systematically has to elevate the human condition. If it doesn't elevate the human condition, if it doesn't elevate human benefit in some way, then it's really technology for the sake of technology, and it's senseless to go down that direction. This is a wheel, if you will, that talks about how IoT architecture framework is connected to every facet of human life today. There's nothing that is done on this planet, and even off the planet, that isn't covered somewhere in here, from soft industries like media and healthcare to retail to manufacturing and energy, on the hard industry side to mobility and transportation. Let's first talk about connected worker. One of the most lofty things that we can do in any science, but particularly with regard to IoT and IIoT, as we're discussing here today, is to improve the employee experience. Improving the employee experience starts with increasing their level of safety. The environments that our employees work in today around the world and will work in industries tomorrow are inherently fraught with danger. In some instances, a high degree of risk. So anything we can do to raise the employee experience relative to being more comfortable, more effective, and safer Connected Worker is one of those programs, one of those things that comes out of IoT and IIoT that allows us to do this, where we can merge culture and strategy, the strategy of keeping our workers safe and ultimately pulling the workers even out of an environment where they have to even worry about being safe. But that discussion will come a little bit later today. So again, designing the employee experience is important because it takes the employee to a new level of safety. It gives them a self-assurance that that industry actually cares about them, and it allows them to perform at a higher level of performance because they have this confidence that they're both safe, well cared for, and certainly well outfitted through the connected worker experience. The connected worker experience, as you see with the woman with the helmet on, gives her a couple of advantages. She's out in the field, but with her in the field is the entire technical library of what she's working on, and it available for her to call up in what can be like a mini HUD display that the military jet fighter pilots use. Also, with her is a camera that can relate back to her shift supervisor, an engineer, a technical representative, somebody that is with her so she's not alone. And believe me, having come up through the operational side in industries like agriculture and energy and chemicals and pharma, I can well tell you that when it's 2 o'clock in the morning and you're working on something and you come across something that you just don't know, something unfamiliar, having somebody at your back, having somebody covering you who can answer your questions, who's seeing what you're seeing, experiencing what you're experiencing, gives you that added degree of safety, that added degree of performance, like someone has your back on the team. You just don't put on a helmet and automatically go to work with a camera and one day everything wakes up and you're just good. It takes work, it takes planning. And in terms of how to choose a connected worker solution, you have to look at certain steps, like who are we connecting to? What are they doing? What kind of information do they need? Because that's going to change from industry to industry, application to application. How do their actions influence their work? How are they feeling? How prone are they to errors, and what kind of errors? What kind of risks are they facing? And also, what data will make the difference to you? And that you can be the person actually in the field, or you can be the person actually sitting at home. You know, the phone rings in the middle of the night, there's a little bit of trouble going on, and you want to feel like you're there with your employee, that you can actually help them in a situation. And I also missed one, what systems do they interact with? Because that's most important, because the environment actually defines what kind of connected worker solution we want and what kind of connected worker solution is needed and will do best for our employees. And believe me, if it's good for the employee, it's good all the way down the line. It's good for the customer, it's good for the company, it's good for the bottom line. In case you have any doubt about what connected worker and setting up a program with a device can be worth in terms of the market, just take a look at this slide. Okay, the connected worker for forecast value by 2039. Believe me, that's not too far off for most of us in the room, $4.3 billion. And in terms of 2019, 402 million, and you can see how it's broken down from oil and gas all the way to power and utilities. Clearly, this kind of solution to help the worker in the field, and connected worker just doesn't go, by the way, to heavy duty industries like mining, construction, chemical. As we're going to see in a moment, it also goes to health. It can go to anything on that wheel we were looking at a few minutes ago. Okay, here's an example of medical connected worker. You talk to any neurosurgeon under the age of 50 in the world today, and they will tell you that modern robots, with artificial intelligence, where neurosurgery is required. We were talking and hearing about nanometers earlier, where measurements to be able to remove tissue from a person's brain, that's scar tissue or subdural hematoma or a blood clot, and we don't want to disturb good brain tissue. Okay, sure, surgeons can do this, but what the autonomous robots are capable of doing today in terms of dialing in is far beyond any neurosurgeon's particular set of hands. And what makes this even more accessible today is that someone in one part of the world can be looked at by an expert who's attached to one of these robotic machines performing the surgery. And if the best surgeon happens to be a continent away or a half world away, that medical talent can be brought to bear in terms of that surgery being performed, again, half a world away, the measurements being dialed in by the autonomous robot. Okay, so far we've talked about connected worker, we've talked about improvements that can be made, and what I'd like to talk about now, switching to the other end of the spectrum, which is away from the worker, but more to the process. So many companies are littered today with examples of programs, IoT and IoT programs having gone awry because they'll start out, they'll be working on a problem, they'll be working on a solution, and they just give up. And they give up because they lose their corporate sponsorship. They lose the faith in what they were trying to do because it's just not producing quick enough. And as it turns out, they actually went after too small a bite of the apple. There was no vision for what was the end point. My proposal is, if I can go in and present a company with a $50,000 solution to a problem that they have, and that's really not part of anything else. It's just a $50,000 solution. If I look at a component, a pump, a valve, what about the environment that those components rest within? What about the process that it runs? The conversation I like to have with clients is, talk to me about your system. What is giving you problems, if anything, in a particular system? I had one application where a plastics, I won't say a simple system, it was complex, it is complex, but a plastics process was just not operating above 60, 65% for this particular client. And so you ask yourself, what's going on? What's going on? They tried everything. They worked on the pump, they worked on a valve, they worked on different piping, all these things, one thing at a time. Finally threw their hands up in the air and took a step back, and we all said, hey, what's going on here? Well, what was the problem? The problem wasn't with any one component. Those were things that operations was trying to do to the best of its ability. The problem turned out to be, we weren't looking at the system holistically. So we took a step back and just downloaded a bunch of data from 7, 8, 9 batches and tried to look for similarities in the data about, was there a story there? And what we wound up doing was something that I've now come to believe that has to be done almost each and every time you're in an IoT or IoT application. You have to do the hard work mathematics. You have to do the hard work analysis. So looking at the data, we performed a multivariate analysis. We found the correlations, and lo and behold, what we discovered was the operators were looking at 42 separate controls for this plastics process. The correlations told us that there were only four had a correlation high enough, close enough to 1, to allow to actually control the system. So what we did was we proposed something that was totally arbitrary to management, and operators were kind of looking at it a little skeptically because they didn't believe in some of the 4 correlation values anyway, but we presented a new visualization to them with just those 4 parameters on it, and created a model with both a baseline and real time, and tuned it, showed them how to do it. and the operators agreed to run by it, and at first run by the model and make the adjustments, and eventually the system, once the model was trained, would make suggestions to do the adjustments themselves. After a year, this system, plastic systems, went from the high 60s to the middle 90%. The operators were still, and still are, fantastically amazed that 10% of the 42 indications actually control the process. Well, this is called process optimization engineering, looking at it from the highest level possible. You take a look at what terms massive IoT devices, these 42 indications in this case. You look at connectivity, communications protocols, security, identity solutions, and machine intelligence. Bring it all together. Notice that the combination on the right has to do with something that we hear about all the time. Sometimes it's forgotten. I suggest it never should be forgotten, and that's security. A lot of questions come up when you're doing a process optimization study and saying, well, how do I do security? I have a simple answer, and you can boil it down or use it all. And the simple answer is double-ended encryption, dual firewalls, multiple passwords, access control, and blockchain over the top. If you do all that, I defy anybody to penetrate that system. So anyway, that's process optimization in this application. Optimization engineering is a new field, relatively new field that's opening up. Typically, operations research statisticians work for companies, think tanks like NTT, for example, and they're only brought in to do specific pieces of problems. But if you're going to do real process optimization, you've got to have a background in mechanical engineering, electrical engineering, chemistry, physics. You've got to have a background in a little bit of people science, because it all comes into play when you're trying to identify and discuss the relationships between IoT, big data, and cloud computing, because you need all of these to optimize system performance. In terms of utilizing an optimization model for prediction, this gives pretty much an X-ray, if you will, of how you begin with the best conditions. You look at a process, you do the process diagnosis, you do the process prediction, and you wind up doing the process analysis, which in most cases is multivariate. To the naysayers in the room who tend to say, oh my goodness, multivariate analysis, where are we going to find these people? I'll get to that in a second. It's a lot easier than you may think. Okay, machine learning operations. In terms of the AI lifecycle for production, I put this up here because machine learning engineers comprised of data scientists, data engineers, and software engineers are a relatively new addition, permanent addition to process optimization organizations, but you need them in order to parameterize and monitor conditions, so you get into what we've heard today and referred to as continuous improvement. Without this, you wind up just going round and round and round the track. But if you have this complete circuit with additional engineering expertise into your process, you're going to find that you only have to optimize once. Once you have the optimization engine established, improvement just is a natural byproduct. Continuous improvement, that is. Here's a little cartoon, if you will, machine learning engineering. This is usually what senior management understands better than the slides that we have been looking at so far, simply because it shows all the basic steps in machine learning engineering and how machine learning contributes to the process. Okay, the one thing I would like to discuss, which I'll just leave this slide up for a minute, is sometimes the answers to our problems are right in front of us. For example, those of you engaged in mathematics will understand the term fractal analysis. Well, when I teach a mathematics course involving fractal theory, what I'll do is take a leaf, and I'll have the students actually look through a microscope or look at composites from a microscope at the various levels, because even though the leaf looks flat on the surface, it's actually a geometric object with different patterns at different levels. noting that and being able to do the mathematics to predict what the optimal vein pattern is in fractal analysis, that has been transposed to the theory now, where, for example, in outer space applications, where space is at a premium, where weight is at a premium, companies now are using fractal analysis to create aperture engines, and the aperture engines actually allow on the same instrumentation stack both power generation from solar cells integrated with antennas for communication. So we have a single device, if you will, that is now both a communication device and a power generation device. This theory has been brought back down to the planet, if you will, and allows our cell phones to communicate with high capacity cloud applications today, and also is being looked at in terms of wireless sensors on the ground that are globally capable and don't have to be in orbit around the Earth. So the whole idea of where did this all come from, it was looking at us right in front of us in the leaf pattern of any leaf on the planet. And when we sat down to analyze it, and like I mentioned, to do the mathematics, we came up with an application that is going to revolutionize ground sensors and our ability to communicate when we are off to the moon and off to Mars. Okay, the future is here today. Developments are going on every single day, every single minute, every hour of the day. The impossible, there's no such thing as things being impossible. The impossible is possible now. It's possible because of people. It's possible because of science. It's possible because we have not just individuals with vision, but we have a generation with vision. Anyone who's stood in front of a bunch of millennial new graduates in the workplace, or if you've been fortunate enough to teach millennials at the university level, you will see enthusiasm. You will see that they are constantly trying to figure out how to do it better, whatever it is, tie your shoe or make $1 million or make a new way to get off the planet. They are constantly thinking about it. So things like worker safety, things like, as I mentioned, bettering the human condition. Every time we do something to make a person safe, to make an organization better, believe me, the business side of things or the return on investment is huge. Like I mentioned before, when I optimize a $50,000 step for a company, okay, so they get the $50,000 step. But if I optimize a process, like for that plastics firm, I spent $300,000 to do the analysis. They come back to the pickup of the 30-some%, 27% pickup, over $1 million year on year. You don't have to do the math to know how much money's in your bank. So again, the future's here today, and it's coming fast. IoT, I predict, will fade into oblivion and be called something else. They'll be called daily science before it's too long. And right after that will be daily application and daily use. So my message to everyone is, let's try and get out in front of this. Let's embrace it and really enjoy it. Enjoy the benefits that we as human beings get from IoT and IIoT. Enjoy what it brings to our companies, what it brings to the shareholders, what it brings to our customers and our clients.
Wonderful presentation, Charlie. Thank you. What can I say? Great insights. We have a couple of questions here. I wanted to quickly dive in because we've literally got 4 minutes before the panel that you're highlighting there goes live next on the next bridge. So let me give you the question here. How can the helmet device help those of us still dealing with COVID, travel restrictions, and remote workers?
That's an interesting question, because if you're, depending on the kind of work you're doing at home, let's say you're not doing work on a computer where it's connectivity, you're possibly reading something, or you're involved in training and you have a question. You may be reading about repairing a piece of equipment, for example, or a new regulation, and you have a question. It's possible that resources could be brought to bear where you could ask that question even from the home environment if you were restricted at home due to the pandemic, COVID-19. Okay, I'll just make quick mention on July 14th, we have a masterclass coming up from CBT, and stay tuned to the Women in IoT panel coming up next.